Welcome to this workshop on control using wireless transmitters. In this video, we will examine the solution to the workshop contained in Chapter 5 of the book Wireless Control Foundation. Initially, we will look at the module which we'll use to simulate wireless control using PID Plus and wired control using PID. We will then initialize a performance indice which we'll use to compare control performance and then introduce a set point change. We will then examine the integral of absolute error and number of communications for the set point change. After doing this, we will reinitialize the performance index and introduce a disturbance change, and then again examine the integral of absolute error and number of communications for wired as well as for wireless control. In the module, we'll be simulating two heaters. In one heater, we'll have a conventional temperature, wired temperature measurement. We'll be controlling with PID and adjusting a wired throttling valve. And the other heater simulation will be using a wireless temperature transmitter and PID plus for the control, which will be adjusting a wired valve. The set point for both the conventional control and the wireless control are common, so a change will impact both. Also, the simulation setup where disturbance impacts both heaters at exactly the same time, so we can compare performance for set point as well as disturbances. The module we'll be using is shown here up in the upper part. We'll be simulating wireless communication of the temperature measurement. PID plus will be used, and then that will be adjusting the output. We'll be comparing it to conventional input, PID, and output. To allow performance to be compared, we'll be simulating two heaters. These simulations are identical, each having the same gain and dead time and time constant. In the wireless communication, we'll be using windowed communication with a deadband of 1%, a periodic update of 8 seconds, and a default time of 16. The PID that we'll be using for the wireless control has the option for PID plus enabled, and so we'll be using PID plus for the wireless control. The tuning of that PID plus, it has a gain of 1 and a reset of 8 seconds. The tuning that we'll be using in the PID for the wired input is exactly the same. That is, it has a gain of 1 and a reset of 8. When we're using PID plus, we tune it exactly as though we had a wired installation. We don't have to be concerned about update or communication. For the simulation, you will notice that the simulation contains a dead time of 2 seconds, a time constant of 6, and a gain of 1. Therefore, in the reset, we're using 8 seconds in the PID as well as in the PID plus. Here we're seeing the module running online with a set point of 50%. We notice that both the wired and wireless control has settled out exactly that set point value. The performance calculation shown at the top, we can set and reset that through this parameter, so we'll be resetting that to value of 0, and now then we'll be allowing it to execute. To demonstrate wireless control, we'll change the set point by 10%, so the set point change has an immediate impact on both the wired and wireless control, and that's being reflected in the simulation of our process. We can better visualize what's going on by looking at a trend. In this trend, we see the set point change in green. The smooth change in the measurement value is being provided by the wired transmitter. The stepwise change is the measurement that is being communicated wirelessly to our PID plus. Notice the output, the smooth change, is again provided by the PID. The stepwise change is due to the PID plus. It only updates its output when we have a set point change or a new measurement. On a set point change down, we'll examine that by changing it down. And again, we'll look at our trend, examine the behavior. We notice that for the initial set point change that we came to exactly the same valve position and value for both the wired and wireless. Again, on the set point change down, we notice that we see a smooth change due to the wired input and PID, and the stepwise change is due to the PID plus. Initially there was some difference, but after a bit of time we notice that the behavior is exactly the same, where we come to steady state at the value of our set point with no oscillation or no variation in our control parameter. If we examine the performance for set point change, we notice there is some difference in the interval of absolute error. However, if we examine then the number of communications, we see that we only had 9 changes in our 9 communicated values versus 270 values for the wired. So by a factor of 20, we had fewer communications in the wireless, and yet the control was comparable. Let's examine now then the behavior for a disturbance change. We'll reset our performance index back to 0, and we'll introduce a disturbance change of 10% and examine its behavior. The disturbance immediately impacts our process, and as the process starts to respond to that disturbance, the control starts to take action. We don't take immediate action with the wireless because the wireless measurement is only updated every 8 seconds. So no action is taken until we get a new measurement. And at that point we notice that the valve action is very similar to the wired PID with a little bit of a delay there. The stepwise change in the measurement is due to then the wireless transmission of our temperature. After a short period of time, we notice that the valve settles out at exactly the same spot as for the wired and also for the control parameter. We'll change our disturbance back down and examine then the behavior for a change in the opposite direction. When we do that, we notice that again we see the change in the process parameter due to the disturbance, and then the control is responsible for correcting for that. We notice again that there is some delay in terms of the wireless control responding, just due to the fact that the communication is only every 8 seconds normally for the wireless communication. But after a very short period of time, we notice the valve settles out at exactly the same value as the wired PID, and also we come to exactly the set point. So we don't suffer much in terms of control performance by using a wired measurement with PID plus. If we then examine then the performance indice, we notice again that there is some difference between the interval of absolute error for wired versus wireless. However, for the wireless we only use 12 communicated values versus for the wired 270 values were used over that same time frame. So this demonstrates the power of PID plus and the ability to use very few communications and do control that's very comparable to wired PID. We hope this has been helpful to you in understanding how PID plus performs versus a wired PID.